For 10.2, we're going to learn about classifying polygons and quadrilaterals. A polygon, poly means many, is a closed plane figure whose sides are segments that intersect or cross only at their endpoints. So if I have a triangle, these are the segments, and they cross at 3 endpoints. So as you can see here, you have 3 shapes: a cross, a triangle, and a quadrilateral of 4 sides. They all have segments that intersect. For example, 12 segments here, and they intersect at 12 endpoints. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, a regular polygon is a polygon with all sides equal and all angle measures equal. And here, let's take a look at the square. All the sides are equal and all the angles are equal, meaning they all are 90 degrees. And here we have a pentagon. Let me write the word pentagon. P-E-N-T-A-G-O-N. 1, 2, 3, 4, 5. We have 5 equal sides with 5 angles equal to each other. And now we have a hexagon. 6 equal sides with 6 angles of equal measures. And here we have 3 figures that are not polygons. This figure here is not a polygon because it's not a closed plane figure whose sides are segments that intersect only at their endpoints. You see this intersection in the middle? It's not an endpoint for this segment. And for this, these curves are not segments. Not segments. So it's not a polygon. And here we have a space. So if the figure is not a closed plane figure, then it's also not a polygon. Okay, let's continue to discuss about more vocab terms. What's the difference between convex and concave? A convex polygon, for example, this hexagon we have here, will be considered a convex polygon only if any 2 interior points, interior meaning inside of the polygon, can be connected with a segment that lies completely within the polygon, meaning inside the polygon, okay? So as you can see, I could put a point here, and connect the dots to form a segment, and it lies completely within the polygon. That's why we call it a convex polygon. And here we have the concave polygon. It was just the opposite of convex. It just means not a convex polygon. If I can put a point here and a point here and form a segment, and if the segment falls outside of the polygon, then we call this concave. And you can see, if you can't remember, concave, this is a C here, this is, well, don't know if that helps. Another double C, concave. Okay, concave. Okay. Now, classifying polygons by sides. If you have a polygon with 3 sides, we call it a triangle. And if you have a polygon with 4 sides, we call it a quadrilateral. Remember, quad means 4. And lateral means side. Okay, and then here you have a pentagon. Pentagon just means, the prefix just means 5. Hexagon means 6. Hept means 7. Oct means 8. And if you have n sides, we just call it an n-gon. Okay, let's do some practice problems. And the instructions here, we need to identify and classify the polygons. We need to do 2 things now. Tell whether the figure is a polygon by writing yes or no. If it is a polygon, then classify it and tell whether it is convex or concave. Explain. Okay, so first of all, this first picture here happens to look like a doorknob. And there's a curve. So this makes it not a polygon. If it's not a polygon, we don't need to classify it. And this one here, the stop sign, looks like a 1, 2, 3, 4, 5, 6, 7, has 8 sides. So if there's a polygon with 8 sides, it's called an octagon. So it is a polygon, yes. That's right, yes, octagon. And tell whether it is convex or concave. If it's convex, remember, if I could draw 2 dots and form a segment inside the polygon, then it is convex. And here, I repeated the problem, there's a curve, or 2 curves, so it's not a polygon. We don't need to classify it when it's not a polygon. And here we have 1, 2, 3, 5 segments. So we call this a pentagon with 5 sides. And it's, yes, a polygon. Again, it's convex because I can draw 2 dots and form a segment inside, and no matter what I do, no matter where I draw this segment, it will always fall inside the polygon. Okay, and in the next problem, it's also, yes, a polygon. Okay, because there's no curves. Let's see how many. 1, 2, 3, 4, 5, 6, 7 sides. 7 sides, we call it a heptagon. And this one, I can draw 2 dots this way and then it lies within the polygon, but if I draw a dot here and connect the dots, my segment falls outside the shape. Again, I see my concave. See, I drew a cave here. No, I'm just kidding. Okay, I would like to go over the different kinds of quadrilaterals, the names of the different kinds of quadrilaterals. Okay, remember, quadrilaterals are polygons with 4 sides. Some quadrilaterals have special names based on whether they have parallel, remember parallel, or congruent sides. The congruent, the symbol, and whether they have right angles, meaning angles with 90 degrees. Okay, the trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. So the parallel side would be here. This one and this one. And this is the symbol we use to represent parallelism. Okay, so these two segments will never intersect with each other. The parallelogram is a quadrilateral with both pairs of opposite sides parallel. So we have one pair here that are parallel to each other, and we have another pair that are parallel to each other. And then the other kind of quadrilateral we have here is the rhombus. A rhombus is a parallelogram with 4 congruent sides. So again, you see that a rhombus is also a parallelogram, meaning it will have 2 pairs of opposite sides that are parallel. Let's see, these are the parallel sides. Parallel, parallel. And these are parallel. I'm going to double it up because they're a different pair of parallel sides. And we need to pay attention to the fact that all sides are congruent. And one of the basic quadrilaterals you probably already heard of is called a rectangle. A rectangle is a parallelogram with 4 right angles. Again, it's also a parallelogram. Okay? And we can parallel, 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 parallel. And got 4 right angles. And now the most famous square. This square, yeah, it's also a parallelogram. So if I say, is a square always a parallelogram? Yes. And if I ask you, is a parallelogram always a square? Then you have to say no, because sometimes it can be a rhombus or a rectangle. Okay? And for a square, remember, it always has 4 right angles, 4 congruent sides. Please don't get the square confused with the rhombus. Okay? The square has 4 90-degree angles, the rhombus doesn't, but has 4 equal sides. Okay, now let's work on classifying the quadrilateral. This first shape here has 2 opposite sides equal to each other, 2 pairs of opposite sides equal to each other, and 2 pairs of opposite sides that are parallel to each other. But the angles are different. And so it looks like a parallelogram. Parallelogram. And this one, this next shape here, we have 4 90-degree angles, 2 opposite sides that, 2 pairs of opposite sides that are equal to each other and also parallel. A rectangle. And this one, we have 1 pair of parallel sides, so we call this a trapezoid. Okay, the rhombus, let's draw a rhombus. Okay, looks almost like a diamond. So these sides are all equal. The opposite angles should be the same, but I didn't mention it earlier. Don't worry about it. Well, you'll learn more about it in geometry. Okay, so now I'm going to talk a little bit more about the angle measures in quadrilaterals. The sum of the angle measures of a quadrilateral is 360 degrees. And I want to prove that. So if we draw a diagonal FH down for these two opposite from the ends of these two opposite angles, you'll form two triangles. And remember that the sum of the angle measures in each triangle is 180 degrees. The sum of the angles. Then 100 plus 100, 180 plus 180 will give you 360 degrees. So the angle F plus angle G plus angle H plus angle I will give you a sum of 360 degrees. And by knowing that piece of information, we can solve problems involving angle measures of quadrilaterals. For example, find the value of x. Let's look for this. And you're given all these different pieces of information. So all you have to do is set up the equation x degrees plus 2x plus 1 degrees. This is 90 degrees plus 68 degrees equals 360 degrees. Now, this may look very, very familiar to the earlier chapters last semester. Okay, I want you guys to make a connection here. Why do we have to go through all the easy concepts at the beginning? It is to prepare you for future chapters, okay? So you need to get into this mindset of, I can't forget what I learned before. You need to build off of it. So here we have 3x, and then 90 plus 68 plus 1. It's 159. And then 3x equals 201. And x equals 67 degrees. Okay, let's do one more. Find the value of y. And this atmospheric trapezoid, 137 plus 97 plus 2y minus 3 plus y equals 360 degrees. Because the total angle measures equal 360 degrees. Okay, and let's do the math. You should get 3y plus 231 equal 360 as the next step. And then 3y equals 129. And then y equals 40 degrees. And that concludes our lesson. Thank you for listening.